Hello, this is Jacob Hawkins. I'm presenting on our third interactive advanced concept presentation. This week we are going to be talking about acid-base reactions. So reviewing some key concepts, what is an acid and what is a base? So an acid can be defined as a compound that dissolves in water to produce hydrogen ions, whereas a base can be defined as a compound that dissolves in water to produce hydroxide ions. Now within those definitions, we can further subcategorize acids and bases as strong and weak. So a strong acid or base will ionize completely in a solution, meaning that it will completely break down into ions. Examples of this include hydrochloric acid, which is a strong acid, and will ionize completely into hydrogen and chloride ions. Similarly, nitric acid, again, a strong acid, will ionize completely into hydrogen and nitrate ions. Now, weak acids or bases will produce some ions in a solution, but the majority will remain as non-ionized molecules. So an example of this would be acetic acid, which is a weak acid, will ionize into some hydrogen and acetate ions, but the majority will remain in the solution as a non-ionized molecule. An acid-base reaction is a chemical reaction that occurs when acids and bases mix and involves the exchange of one or more protons. The Bronsted-Lowry theory, also known as the proton theory of acids and bases, states that a compound that transfers a proton to another compound is an acid, while a compound that accepts a proton is a base. So this is essentially another way to describe or define acids and bases that's a little bit less dependent on the chemical reaction happening in an aqueous solution. Additionally, it's also just generally describing what's happening in an acid-base reaction. So you have an acid, which is donating protons to a base that's accepting them. So in aqueous acid-base reactions, they tend to produce water and salt. And in that sense, there are neutral reactions because you see that we have acids and bases that are reacting to produce neutral products. So a neutral H2O and a neutral salt. So examples of this would be hydrochloric acid, which is obviously an acid, reacting with sodium hydroxide, which is a base, to produce water and then what is ostensibly table salt, sodium chloride. So to demonstrate the concept of an acid-base reaction, we are going to do a simple experiment today where we add baking soda and vinegar together in a bottle, and we're going to see what happens. So I am going to transition things over now to a video, and then when we resume on the final slide, we'll talk about what happened and theorize why it happened. Hello, this is Jacob Hawkins. I am presenting on our third interactive advanced concept presentation for general chemistry. This week in class, we've been discussing reactions that occur between acids and bases. So we are going to kind of be demonstrating a reaction using just household objects. So in this case, our acid will be just distilled white vinegar, and then our base will be just some regular household baking soda. So the instructions are pretty straightforward for this experiment. So we are just going to be adding some baking soda to a paper towel, putting that paper towel into a bottle, adding some vinegar, and then reporting on what happens. So there are no specific measurements that we've been given. So I am going to be adding probably, let's see here, about a tablespoon of baking soda. I'm going to put this in here as best as I can without breaking up the paper towel. So we see that. And once again, no specific measurements. So I'm just going to be filling this up, to kind of cover the paper towel and the baking soda, trying to make it a little over equal. And then we'll see what happens. I'll just pour in the rest of it. Okay, so what's happening is the baking soda is rising. I'm sorry, not the baking soda, but the reaction between the baking soda and the vinegar is causing CO2 basically to rise up as bubbles and almost escape the bottle, not quite. All right, so I won't keep everyone to watch the entire thing. I'm sure it'll take a little bit of time. But once again, just to summarize what happened, adding the baking soda into the bottle with the paper towel and then pouring vinegar over, a reaction was occurring between the acidic vinegar and the basic baking soda, and it was causing a release of CO2 gas, essentially. Those were the bubbles that we were seeing. So on the next slide, I'll kind of break this down in a little bit more detail and kind of theorize a little bit more clearly why this was happening. So stay tuned. So what we saw is when you add baking soda and vinegar, a chemical reaction occurs. So there were no exact measurements given for this experiment in terms of either the baking soda or the vinegar, but we were told to wrap up whatever amount of baking soda we had in a paper towel and put that in the bottle. But I think that was really just meant to have a delaying effect on the chemical reaction. I think that if we had put the baking soda and the vinegar in the bottle together at the same time, the reaction would have occurred right away and it wouldn't have been very visually pleasing. But by kind of delaying that reaction, it gave us time to fill up that bottle with a lot of vinegar so that when the reaction kicked off, it kind of had a dramatic effect. So this was pretty obviously an example of a acid-base reaction. We had vinegar, which is an acid, reacting with baking soda, which has sodium bicarbonate, which is a base, and it kicked off a chemical reaction. Now in the video, I was talking a lot about CO2. We saw the bubbles form, and I said that was CO2, and that definitely is a product, but that's only the visible product. So that's the thing that we can kind of most obviously see as the bubbles are forming. But remember that an acid-base reaction is involving acids donating protons to bases, and that can result in any number of products. So we saw the CO2, but also what we weren't seeing was the chemical reaction forming sodium acetate and then also water H2O. So remember a few slides ago, I talked about how acid-base reactions tend to produce sodium and H2O, and that is what we ended up seeing with the sodium acetate in the water being produced. And this also kind of demonstrates what's meant when we say neutralization reaction, because we had an acid and a base reacting to form neutral products. So this experiment was relatively straightforward. I hope that people enjoy this and maybe take something away from it, and I look forward to seeing everyone else's presentations.